Welcome to Flink Forward Asia 2024.
Let's be ready, ladies and gentlemen. For the first one, we have a case study, Mekari case study that will be delivered by Mr. Fajar Tontowi. He is a lead data engineer in gestation and analytics who will enlighten us about implementing CDC to MaxCompute with Apache Flink. So please welcome Mr. Fajar Tontowi.
Okay, morning everyone. My name is Fajar and I'm from Mekari. Today I will present to you about what improvement we do on Mekari with serverless Apache Flink in Ali Cloud and with MaxCompute for our data sources. Okay, for the beginning, I will introduce to you about Mekari first. Mekari is one of the largest company in Indonesia that provide some services to help other companies to grow in many areas. We have 6 major product and services Mekari. We have Talenta, Journal, Klik Pajak, Flex, Kontak, and Design. It will be help to company to grow in many areas in certain area. So today we have 800K registered user on Mekari, 35K business connected to Mekari, and we operated in 20 cities around Indonesia. Because on that, on daily basis, based on our user, we have more than 4 terabytes of data need to be processed on daily basis in a real time and batching processing. And also because we have several products that I mentioned before, we have journal and etc. For the connecting the data from the backend to our environment of the data, we're using CDC. And currently we have like more than 800 table being processing using CDC in our pipeline. And also there is more than 40K event is generated per second. It's come to CDC event or any our microservices in Mekari. So this is the legacy architecture in Mekari. We have previously we using AWS as our cloud services. We have some of data sources like relational DB, third party, file, non-relational DB, and external data. For relational DB, to connect all the database from all our product, we're using CDC. So like I mentioned earlier, from the CDC data, we sync the data into our data lake. In our data lake, we separate the zone in 3 zones. We have a raw zone, validated zone, and analytic zone. Raw zone means all the data from the sources will be put into the S3 in the format as it is like in the sources. So if the sources, the data is from CSV, we'll be put the raw zone as a CSV file. Also if PDF, JSON, and Parquet. For CDC data, we sync the data to raw zone in Parquet file contain metadata from DBZoom. So the Parquet file will contain the data from DBZoom. After that, there is validated zone. In validated zone, basically, we do some cleansing of the data from the raw zone, standardized data, and do some of the duplication of the data, and put all together in the validated zone in standardized format in Parquet file. And after invalidated zone in Parquet file, BI or analytic teams can do some creating some data mart or data warehouse, using Athena to query to the validated zone. For data processing engine, we have to EMR, Athena, and Python. So data from the raw zone and validated zone to do processing, transformation, standardized, and cleansing, we use EMR and Spark on that. So will be Spark or job will be running on the EMR to do some the processing of the data from the raw to validate. We have one big cluster EMR to serving all the product in Mekari. So the data orchestration we use is Airflow to manage the workload and the jobs to sending data from raw, validated, and data mart or data warehouse. And we're using S3 as our storage engine. We pull all the data into the S3. So this is the, we have some BI tools also. We have a connected Athena with a Tableau and Metabase, and also API for external data if some of customer want to pull our data, they can use API we created, and also machine learning for predictive modeling from data science team to create a model from our data in a data lake. Okay, next, what is the challenge of the old architecture? First is about cost inefficiency, because when of the largest of the data is coming, our usage is growth, the data always increment on daily basis, the expensive of architecture when we need to more resources in EMR. So like I mentioned before, we use one EMR cluster for serving all the product to processing like a standardized and deduplication and anything. We use EMR cluster. So we need always vertical increase the resource in every day if we need some more resources. And the cost of the EMR is so huge and it's not efficient for of data volume increment on daily basis. So the second is hard to calculate the resource needed for every product. Like I mentioned before, in Mekari we have several products. We have Talenta, Journal, and etc. And because we have one EMR cluster, it's difficult to us to calculate how many resources or how many costs for we processing data from Talenta, from Journal, and for any other product. So because we in previous architecture, we just only one F1 cluster for all the products. And the second is about alert and monitoring data issue. Because if there is some, we always have been issue like data discrepancy, right? In data warehouse and data mart layer, we always be facing of the data discrepancy. So if the data discrepancy occurs in data mart layer, it will be difficult to see the root cause if the issue is happen in the raw zone, because in the raw zone the data is still on the format like in the sources. So the format can be CSV, PDF, JSON, etc. So it will be difficult to us to find the issue in the raw zone. So and also it's difficult to us because not standardized of the format from the raw until the validate until the data mart and data warehouse. We having challenge to create some monitoring alert for discrepancy, and we talk about data quality issue, nullness, any other metrics of data quality. We want to maintain data quality from raw until the data warehouse is clear. It's also we have some challenges on that. So, and the third is about real-time analytics. If we want to create some real-time analytics, currently we having some difficulty, like because in real-time data is stored in the raw zone data, and in the raw zone data it's still formatting on the different data type like JSV, JSON, and etc. So it's difficult to analytic to query directly on that. So it's so challenges and difficult to create real-time analytic on the legacy architecture. And because the data is not yet standard from raw until the data warehouse, it also make some difficulty on that. So this is the interesting part. This is what the new architecture of we do in Mekari. We using Ali Cloud services for our cloud service, and we use MaxCompute for our data store, and we use Flink serverless on Ali Cloud service. We use Apache Flink on Ali Cloud service. So basically this is Flink with manageable service by Ali Cloud. So the difference is about the legacy architecture. With the new architecture is all the zone is already standardized on the table layer. So in the raw zone until analytic zone, the format is on table and data will be stored on the table. From relational DB to raw zone, we use Apache Flink for connect CDC data from our sources like in MySQL and Postgres. We deploy the data using SQL deployment in Flink, so it's easy to us to connect the data from DB MySQL and Postgres because we just need to store the SQL deployment and create some SQL script to put the data, to sync the data from the relational data to raw zone table. In raw zone table is data already formatted on table, so all the data already can be queried from analyst OBI team. And on validated zone, analytic zone, it's same zone like before, but difference is just the format is only on a table format. And we use data processing engine MaxCompute. We processing the data using query on all the process. From the raw zone, we process the raw zone from validated zone. We do some cleansing of the data, standardize the data, and deduplication of data with the query. It's making easier the process because we just need tweaks the query if we want to do some processing of data from raw zone to validated zone. Okay, this is the new architecture and the improvement we do on Mekari. The process, so the advantages of the current architecture is cost effective because in Flink, we can distribute the resource based on our product. Like if journal need more resources, we can put the more resources in journal. If Talenta need more resources, we can also put more resources in Talenta. It's possible do in Apache Flink to on that. So and it will make easy to us to scalable the data also, and make easy to us to calculate the cost for each product because sometimes we need to calculate the cost based on the product we have. And second is performance and scalability. Because of the connection, currently we just use CDC and Flink, so we cut some of the process and we just need some of SQL deployment to creating some SQL script to deploy in SQL deployment, and we'll easy data from the CDC like Postgres, MySQL, and any other RDS sent to MaxQuery. And also we doing with autopilot mode in our SQL deployment in Flink. So when some spike data event in any other activity in backend, so the Flink will be automatically increase the resources of the SQL deployment. So it will be easy to us if there is some peak data event in sometimes they will automatically increase the data. So it will be easy to manage the server and infrastructure in for data engineering teams. And the third one is real-time analytics. So many our clients is asking to us to make a real-time dashboard for them because they need real-time analytics for making some decision about churn or anything they need. So currently with the new architecture, we can do real-time analytics. We can do the transformation on real-time basis on the Flink. We can do some query on the Flink SQL development directly to the RDS and put directly to our analytic zone like data mart on data warehouse. So it will be help stakeholder to their company growth with real-time analytics. So the impact on technical benefit, automatically scale on Flink is make us our easy to maintain the workload of the job. It's easy to us to not always monitoring the job, right? Because it will easy if we have a feature like autopilot in Flink, it will easy to us to performance the issue. So, and the serverless architecture remove need for infrastructure management, allowing them to focus on platform development. Serverless architecture make us too easy to deployment some infrastructure. So, like I mentioned earlier, we just need to put some SQL script and SQL deployment. We cannot build some monitoring alert or etc. We can use monitoring alert in Flink services or MaxCompute services. So it will easy to us to maintain the serverless infrastructure. So our team can be more focused on platform development to make our platform can be more easy to use and can be easy to our customer to check the data and the fastest readiness of the data. And the third is a integrated end-to-end solution from data ingestion to analytic environment. So the data integrated end-to-end solution from the RDS until the our analytic zone is using Alibaba Cloud Services, and we have like centralized monitoring on that and centralized monitoring alert on that. So it will easy to us to having some issue if there is some data error or some anomaly data, it's coming from raw, validate, or our CDC infrastructure. And from business perspective, there is some benefit also. We have, with the new architecture, we have a cost reduction on infrastructure about 30 until 40% because we do some efficiency and resources like I mentioned before. We make every product have efficient resource, so there is not leak resources on every product. And also we maintaining the CU or compute unit on the Flink correctly and manageable in Flink. So we can manage cost reduction of infrastructure until 40%. And also for the SLR readiness of our data is increased like 40%. Basically, our data can ready on like 8 AM until the data mart today. With this new architecture, the data of readiness can be ready on 6 AM. It's good for our customer because the more ready of the data, the more can use the data. Okay, the next part is about real-time data capability. We provide some quick insight because now we can provide them with real-time analytics. And also we collaborate with BI to create some dashboard real-time, and we can help the company growth with real-time data so they can make more faster decision with correct data in real-time basis. And the third is the flexibility of serverless of infrastructure, because the flexibility of the serverless infrastructure we deploy on the Alibaba Cloud. Now we can focus and creating platform to our customer and our user. So it will be make easy to us to focus on the future long-term visibility, to see the opportunity to what can we growth and support other evolving technology in Mekari. Okay, I think this is my last talk about what we improve in Mekari from the legacy architecture to new architecture. I hope this can enlighten us to give some new information, and feel free to reach out to me in my email or link in social media. So if you want to some question or need something discussion about this, feel free to reach out to me. I will happy to share to you about everything what we do to improve our architecture. Thank you, everyone.